All right, good afternoon, everybody. Thank you for taking that echo away, Carter. My name is Kurt Ferguson, and you are joining the Level Up with IO-Link presentation from Automated Dynamics. We're glad you're all here. I'm one of the Houston regional managers. Just to get started, what we're going to be covering today is products and technologies in regards to IO-Link. Carter's put together some great demonstrations that he's going to go through. So it should be a pretty good session. For those that aren't aware of who Automated Dynamics is, we are a manufacturer's rep firm based in the South. We cover 6 states, Texas, Oklahoma, Arkansas, Louisiana, Mississippi, and Western Tennessee. And as you can see on the map there, everywhere one of the little Fisher-Price guys is at is where we have one of our territory managers. And then the blue guys those are the guys in red. The guys in blue are going to be our field application engineers. They are based in San Antonio, Dallas, and Shreveport currently. And they are there for more advanced technical support for whatever you may need on our more advanced products. And actually, a couple of them are sitting in on our session today. Next, we are going to have Carter Massey presenting on the IO-Link topic. Carter, can you index the slide for me there? There he is. That's the guy you're going to be hearing here in just a second. So Carter's been in control and automation since 1992. He's been with Automated Dynamics for 22 years, and believe it or not, we've actually got quite a few more guys with more tenure than him, even though his hair is that gray. Yeah, we do have more guys. And he's been married for almost 30 years in a row. So congratulations on that, Carter. Everybody is going to be muted on here. We ask that if you do have a question, please put it through the chat. In the upper right-hand corner, there is a chat bubble that you can click, and make sure and send your question to the organizers. Are going to be the ones that are monitoring the chat. Carter's going to be presenting, so he's not going to be looking at those questions. So please make sure and send those to the organizer. Just a quick tip, if you want to be able to view Carter's camera, which is where the IO board is on a much larger screen, up at the top where it says View Everyone, if you'll click that and you'll change it to Active Cameras, that will make the Carter's screen much larger for you. And then if you want to take it a step further and you're running 2 monitors, there's a control box on the right-hand side of the screen in a rectangle. Inside there, there's a circle with 2 squares. If you click that, that will actually detach your camera, so you can drag that to the other screen, so you can have his board on one and the presentation on the other. So just another tip on how to do that there. This is going to be a recorded session. We will be sending that out afterwards, and please keep an eye out for a survey that we'll be posting later in the presentation to get your feedback. But other than that, Carter, take it away.
All right, let's find I'm coming. There we go. I'm coming. Yeah, exactly. Switching around windows is not my strength. Well, good afternoon, everybody. Appreciate you guys popping on. And if you are here, that means that you have got some interest in or some experience with IO-Link. And we're here to give you some of the overview of this technology so you can level up with IO-Link. I'm a little up in years, but I'm adopting some of the youngsters' verbiage, so I'm learning about leveling up. So we're going to talk about IO-Link today, and what kind of things are we going to cover? The agenda is we're going to talk about what IO-Link is, as well as a very important topic of what it isn't, because it definitely something I had to really come to terms with when I started talking about it. Ways to use IO-Link. So this is less of a how-to and more of a why-to and a what-to. If we want to get into some deeper dive technical sessions, we'll get our field application engineers involved and let them teach you all the things they've learned about this, whether it's interfacing with your PLC, how to get more from the diagnostics, that kind of thing. So we're definitely up for that. The advantages of an application approach to IO-Link, and really most of our solutions haven't been, hey, how do we use IO-Link? It's been applications we've run across that IO-Link has just made a lot of sense. And then of course we're going to talk about IO-Link products and play with the fun demo board that's here in the conference room. One thing that I'm giving a virtual presentation where I can't really look at your feedback, I can't read your body language, can't see you roll your eyes when I make a lame joke, so I had to introduce my own oohs and ahs. So this is my oohs and ahs slide that hopefully you give us some good feedback, whether it's good technical content or a dumb joke, and we'd love to get your feedback in the chat session as well. All right, so what is IO-Link? Well, we're going to start by talking about actually what it is not. Because when I first heard about IO-Link, and it's been 8 to 10 years, my first reaction was, oh great, not another field bus. You know, I've been around a while. I saw the introduction of the CAN-based networks, whether it is DeviceNet, SDS. You got something from Profibus DP that came out. All of these field bus technologies and topologies came out with the goal of making things efficient, giving diagnostics, saving money in the long run with wire savings, that kind of thing. What they all had in common is that you needed a large upfront expense. And not everybody was ready to bite into that. You really had to have the 6-month ROI or better, I think, to really adopt that technology. Of course, the price came down. People adopted more and more, but there were some challenges with it. So when I first heard of IO-Link, it was like, oh man, I really don't want another field bus. As we'll talk about today, it is not a field bus at all. This is a device-level communication protocol that brings a lot of benefits into our world without a lot of cost. So it isn't a new field bus. It also isn't something to run from. Hopefully we'll talk about some applications, some products and technologies that kind of excite you and maybe want to give it a try. In fact, I think one of the keys to this is you don't have to make a big investment. You can stick your toe in the water and just give it a test before you implement it across your entire control platform. Also, what is it not? It is not a social media site for people with lots of credit card debt to connect with each other. That would be IO-Link. So that's definitely not what it is either. And their phrase is in love and in debt. So I'm going to take a sip of coffee, enjoy those oohs and ahs, and move back into the presentation. So the historical automation system involves field level devices. These could be discrete on-off sensors. They could be analog devices taking true readings. They can be actuators, so inputs, outputs, that kind of thing, that we're doing something in the field. Historically, we've been wiring those either directly back into a PLC or into some type of remote I/O module to save on wiring and run less cables, that kind of thing. And this is kind of where all the data has come from. All the data has been located, in the PLC, in the remote I/O, but down here we were just getting on-off signals or actual, measurement from an analog sensor. So we are in an age right now where people are not going to want less data, they're going to want more and more. The key is, how do we get useful data and turn it into something we can actually use? So that's what was going on. So what is IO-Link? IO-Link is a point-to-point connection. Again, not a field bus. We're not daisy chaining IO-Link devices together. We don't have to go out and give them an address like we do a DeviceNet device or something like that. If you're using an analog sensor, your analog sensor typically connects to one point on your analog I/O card. IO-Link will work the same way. If you have an IO-Link device, you're going to connect that to one port of your IO-Link I/O card. Here I've got some IP69K, IP67 type IO-Link devices. So here I got 4 ports on this one on the left side of the Magic Board. Each one of those ports is an IO-Link master port and will talk to an IO-Link device. So it is point to point. It's an open standard. For you as a customer can take advantage of that because you don't have to choose a company up front. You can pick and choose from the different topics and the different products available. In fact, if you're going to implement a full system, you might you should use sensors from us, many masters from us, but you can also go get a starter or an actuator or something like that from another company. And the way that you implement them into your IO-Link system, there's a lot of consistency there, so you don't have to relearn everybody's method. What kind of data can we get? Well, typically we're getting measurement data. Whether it's a distance from a laser measurement, a pressure value, we're getting status of a sensor. Are we on and off? Do we have, what kind of health do we have? Do we have a stable target? And more as we'll show you. What's really cool about this is that now we can get lots of information from field devices without having to have special cabling. If it's a DeviceNet type of implementation, well, you need a CAN cable. So you got your power, you got your signal, it's typically shielded, you got limitations there. Or expense. If it's analog, then a lot of times you're using a shielded cable. Shielded cable's fantastic, but it's also a little pricier. Not as many people stock it when it comes to like M12 devices, and you have to have different cables for your analog and your discrete. IO-Link is designed to run on a 3-wire unshielded cable, the exact same cable as if you've been using on your PNP proximity sensors for years. And you can run that up to 20 meters. So each one of these ports on this block on the left-hand side can have a 20-meter cable that's going to land at an IO-Link device with that three-wire unshielded cable. You also get to have some diagnostics information that we'll talk about. You can actually use this for configuration, which can be very helpful for some smarter, more intelligent sensors. And then you can get fast updates. You can select the update speed on each port in some cases, but you can get it as fast as 2.3 milliseconds. So what does it look like when you're deploying IO-Link? Well, the top layer, we still have our field bus. You know, these days, the most common ones are Ethernet. The two we run into the most are Ethernet IP and Profinet, which both have lots of different options to putting things on IO-Link. Then in this middle layer, now we've gone to intelligent sensors that have the IO-Link microchip embedded in them that's giving us the connection data, the measurement data, the diagnostics, and all of that. So now I heard somebody say it, I think it was Turk, and it really plays well, is that we're now putting intelligence into the last meter of cable run. And then some devices, you just still have to have good old I/O. So whether it's a push button, a simple PNP proximity sensor or something, this device here and this one here, these are IO-Link hubs. So just like your old multi-port with the multi-pin home run cable junction box, this is the same type of thing but for IO-Link, and we'll talk more about that. But now you can put discrete on-off signals onto the IO-Link network as well for your application. So what kind of data do you get? Well, again, we're not going to get too deep into the technical weeds, but you get two types of data. The main type that you're going to get every cycle, every scan is going to be processed data. This is typically your measurement if you're doing a laser measurement sensor, or if you're taking a proportional valve to the right location, then this is going to be the actual location and a digital value that you're going to be sending that valve. Other types of data, which we call acyclic, which is going to be you go poll for it on a timed basis, or if some event happens, you can go ask for specific things. This is some of the configuration data, like what mode is my laser measurement sensor in? Is my output set up for NPN or PNP? How many hours of operation have we been going? You can even get down to the part number or the serial number of the device. And so those are things you go ask for as you want them or need them. But the process data is going to be going every scan. So let's get into some of the application advantages of IO-Link. First is just sensor configuration. Here I've got on the board, I've just got a photo eye, just a retroreflective photo eye that happens to have IO-Link inside of it. But in my application that I want to talk about right now, I'm not quite ready to deploy this into the field as an intelligent IO-Link device. I just want it to be an on-off sensor, but I want to do some intelligent things to it to determine when the sensor turns off and on. A common one, like in the material handling world, might be just put a time delay on the sensor. Right now, if you want a debounce timer or something, you might have to go into your PLC program and make that change. Well, what if instead we can just put it right into the sensor? So again, think of this as just a PNP output sensor, but I'm going to use IO-Link, and let me change my screen share here. And we should be going to a software called Pactware. All right, so now I'm in some of the data available on this retroreflective photo eye. Configuration is really what I want to show you here. If I just want this to be have a timer put into it, I can come into, there's several different software packages. This happens to be Pactware, which we get from Turk. I can come into this software, decide that I want a 2.5 second delay timer, enable the timer, and then when I send it down to the sensor, I can go disconnect that from my IO-Link master and go put it into my standard PNP sensor application, except now I've got a timer. You know, this is we don't just have these bricks for field locations. this is a USB single I/O link master. So I can just connect one device to it through the M12 connection, USB this to my laptop, and do some configuration for my sensor. So putting your toe into the water, you can just do something as simple as that. Another great example is this is a temperature transmitter and a temperature switch. So it's got a 4 to 20 milliamp output, it's got a PNP switch point output, and it has I/O link. But again, I'm not ready to deploy I/O link into my control architecture. I just want to take advantage of it as a configuration tool. This will come from the factory with 4 to 20 milliamps scaled at 0 to 150 degrees C. Well, I might have 4 different applications in my facility, and I want them all to be scaled differently, and I don't want to have to purchase something expensive or purchase 4 different part numbers. So again, taking my single USB master, I can connect to the sensor, open the same software I was just showing you, go in and set the 4 milliamps for, 50 degrees C and 20 milliamps for 200 degrees C. You can also do it in Fahrenheit. But then once I do that, and I can set a switch point for 100 degrees, once I've set that up, I can go disconnect it from my laptop and just go put it into a 4 to 20 milliamp application or a PNP switch point type application. So what that allows you to do then is have the same part number on the shelf, a saved file for each of your locations, and now you're utilizing I/O link without having to change anything with your PLC or your control architecture. So that's putting your toe into the water with sensor configuration. And we'll come back to those 2 products later to show you some cooler stuff. All right, and let's get back to the slides. All right, so 1 is sensor configuration. 2 is saving wires and saving money. Besides just the data, we can now deploy things and save money just in the implementation. So this is an example of our tried and true way we've done things with just discrete and analog I/O. So you might recognize this is a contactless encoder for a 0 to 360 degree position. This is a temperature transmitter with a 4 to 20 milliamp output. And these are, traditional multi-port bricks, kind of like this on the camera. You've got up to 16 discrete I/O points and a multi-pin cable coming back, so you can have a pin for each device. This is something pretty common. You'll notice on the gateway here at the I/O rack, we're taking up multiple modules, so we have enough discrete I/O, we have an analog, and we have an SSI for this, and then of course there's landing the wires. Pretty clean historically. Well, now what we can do is, instead of using an SSI encoder, which you use SSI because it has a lot of resolution, now we have an I/O link encoder, so it's the same package, same technology, just a different reporting format. This temperature transmitter, we now have an I/O link version of that, and then instead of these multi-port bricks with the multi-pin home run connector, we now have a multi-port brick like this one that just takes that 3-wire unshielded cable back to the I/O link master. And so we've saved with our multi-pin cable, which it's a little more expensive and they can be difficult to run, gone down to the 3-pin unshielded cable. Now you look at the wiring on the left-hand side, we've taken that entire application and put it on one slice. The reason is this slice here is a 4-channel I/O link master, and I've got 4 I/O link devices out there on the board, the encoder, the transmitter, and both of my discrete I/O blocks. So here we're mixing measurement and discrete I/O all in this I/O link format. So what about cost? The good news is a lot of these sensors are, compared to analog, are the same or less than their analog brothers and sisters. And the I/O cards themselves are the same or less than your typical analog I/O cards. So there's the wiring in the cabinet. We've saved panel space and saved wiring, but what about just the hardware? And there's a side-by-side. So if we're looking at just the hardware, on the left-hand side is our standard distributed I/O, which you're looking at a list price of $2,300. And then, but just going to the I/O link, we've reduced that list price spend by about $700. So we've saved in hardware before we've taken advantage of the extra savings in panel space and wiring. So I always thought that those 2 boards told a pretty good story about I/O link. We talked about this hub. This is the hub we were just talking about. So it does all discrete. So this is an application I wanted to mention to you, in that we're not doing any type of measurement, and the customer that called definitely didn't say, hey, can you come solve this with IO-Link? What he did is he said, I've got this application for a put-to-light system. So basically each one of these bins is something that they'll put a product in when they take it off the machine and scan it. Whenever they take it off the machine and scan it, the appropriate light will light up. They'll go put it in the bin, and then you may not be able to see it with your resolution, but each one of these is also a touch button. So each end device is a light and a touch button, so it's an input and an output. So using my 16-port discrete I/O hub, I'm able to take a cable from this is a block here on the right side of the board that's got 8 IO-Link master channels. I can take a cable up to 20 meters to this hub, and this is just discrete I/O wiring. So I was able to do this entire thing without landing a single wire, taking advantage of what the IO-Link has to offer, and only using one IP address. So this worked out to be a very, very cost-effective way of doing this. Simple, we didn't have to run multiple Ethernet cables, and we were able to use just the 3-wire unshielded cables, which made them very easy to route. And also, even though I'm using different colors for the IO-Link cable and the field cables, they're actually could be the same. So pretty slick system there. And again, this wasn't an IO-Link request, it just made sense to take advantage of what IO-Link has to offer. Now we get into measurement. One of the key areas I found that IO-Link makes almost an obvious decision is when we're mixing measurement and discrete. So factory automation, where you're doing a lot of measuring, or some process automation. Historically, this sensor here on the right, this is a Banner LTF12. It's a 12-meter range sensor, but it performs very well down within the first few meters as well. If you had the 4 to 20 milliamp version of this, if you got a 12-meter sensor and a 3-meter application, then you normally want to reteach that output so that you're getting 4 to 20 over 3 meters instead of 4 to 20 over 12 meters, because then you're not using the full span. So to do that, you have to teach the sensor the appropriate ranges, which is not hard, but it's still something you have to do. And then when you run your shielded cable back to your analog input card, then you've got to go scale the PLC values themselves as well, because now we're getting 0 to 65535 if it's 16-bit, or 0 to 4096 if it's 12-bit, and then you have to scale that. If we use IO-Link, conversely, and this is my little shoebox PLC, it's kind of weak, but I'm going to do an ah for the dad joke. Now we're using an IO-Link version of this sensor. Well, I don't need to do any teaching to the sensor, because the IO-Link message contains usable engineering information, engineering values. So it's going to be giving me millimeters of measurement in its process data, that cyclical data that happens every scan. So now I can go deploy all 5 sensors. I can set my PLC up just to know what the millimeters mean to me, doing my loop control. And then if that third shift breakdown happens, anybody can take a unit off the shelf, just remount it, plug the cable in, and now we're up and running again without any teaching or rescaling of our PLC. And oh yeah, we're using that 3-wire unshielded cable. One of our field application engineers, John Lirette, brought this up to me last week after we were going through the presentation. Another benefit of using this for measurement data is resolution. You can see here that the LM gives 19 bits of measurement information. Well, most analog PLC cards on the market that I'm aware of are 12-bit, and you can get some that are 16-bit. But now we get the full 19 bits of measurement, again using an unshielded cable, and then just pass that complete measurement value over an Ethernet message. So we also get to take advantage of the full resolution of the sensor, if you will. So we don't want to try to send 19 bits and jam it into a 12-bit device. All right, I like this slide because it shows the different types of things you can do with IO-Link that used to be different IO cards or different modules. So with this application, I've got some discrete IO and I've got some analog IO. Historically, we would, out in the field, and I'm using the camera now, we might have to do 2 of these blocks. This block in my left hand is just a 16 discrete I/O block. Any point's an input, any point's an output, with with its own IP address. And then this one has 4 analog signals. So in this application, you would have 2 different devices to purchase and mount, 2 different IP addresses, which again, not a big deal sometimes, but sometimes the cost and the extra mounting might turn you off the application. And historically, you got a lot of empty ports because I might only have 1 analog device. So now I've had to go put an IP address out there for 1 analog sensor. The other issue you might run into when it comes to indication devices like this incredible Banner TL50 tower light, this is a 3-color and an audible. So 4 outputs required to operate this device. Where if you're using your traditional I/O block, you're only going to get 2 signals on each of these ports. So, Banner did some cool stuff, of course. They come out with a double cable device that has 2 connections for your I/O block, but you've also just taken up 2 ports of your 8-port I/O block. So with I/O Link, and back at our slide here, now I've got my analog, pressure or temperature transmitter. I've got my distance laser sensor giving me an absolute measurement. This is a easy array, so it's actually giving dimensioning of whatever's passing through, like a box or a log. We got our encoder that we've already kind of talked about. Now we've added indication devices. So now I can get, and if you're looking at the board here, I get a 10 segment TL50 tower light that I can handle with just that 3-wire connection. And so now I'm only taking up 1 port with my indication. To me, adding indication to this makes it even a more obvious conclusion sometimes. So now the other thing I've added here is Turk has a couple of RFID readers that have I/O Link. So if I had an RFID drop station where I need a photo eye to trigger that the package is there, let my reader read, and then give me some kind of indication whether it's what I'm expecting to see or not, now I could use something like this 4-port reader, this 4-port block here on the left, and I've got my RFID reader, my gate sensor, and my indication device all on one Ethernet drop. So that's the kind of thing that starts to really save IP addresses and save the number of blocks that we have out in the field. So it was when a customer that I work with had some analog and some discrete and indication that it really just kind of popped my eyes open on what we have here with I/O Link. The other thing, and I'll show this a little more detail later, is data storage mode. If I've got the same sensor that I'm using in multiple locations, then I can just take the standard factory default unit off the shelf, go plug it in, and if you have data storage mode enabled on your master device, it will send the proper configuration into the sensor for you. So if you have the same device with multiple configurations in different locations, the I/O Link master can let you just plug and play those with ease without having to worry about which configuration is in which device. And we'll show a little demo of that shortly. And of course, IIoT data. This acronym meant nothing to me for a few years. Everybody wants data. What can we do with it that's useful is really where it's starting to make a difference now. One of the biggest things I see people implementing IIoT for is predictive maintenance. We're just trying to prevent downtime. And if you can understand why you have downtime, then you can go to prevent it. So I'm going to switch the screen here. I'm using a little red line HMI connected to my devices here. HMI screens are tough to see. So through the camera, so I'm going to switch you to the web browser. Let's go home. Let's go to my photo eye. So you guys should see the photo eye here. What I'm showing here is we've got output, whether it's off or on. We have a health state, which again, you can monitor whether or not the sensor is even out there or not. Then we have a marginal light state and a signal strength. Signal strength just tells me how good of a signal return I'm getting from the photo eye. You can use that by itself to let you know if you have a potential issue happening. In this example, I want to talk about the marginal light state. So if you have an application where every now and then your line goes down because a reflector gets covered with flour, dust, or something like that, and you have to go clean it off, well, you can start monitoring that signal strength and set basically a little alarm in your PLC that if it drops below, if it changes a certain amount, next downtime, and I'm actually turning the sensor slightly. Next downtime, you can go clean off that reflector. I've set this marginal at about 159. So now if you look at marginal light state, it just turned on. So I also just got a bit that told the PLC that I'm still working, because you can see the off and on at the top is still working, but I've got marginal gain. So now on the next PM, you can go and have somebody just clean out that reflector without taking your line down and wondering why your line just went down. And we'll come back to this sensor in just a little bit. So that's just one of the simple ways that you can use the data from an IIoT or Industry 4.0 method. Oh, now I got to go back to my slides. What's next here? Okay, what kind of products do we have with IO-Link? So talking about the Turk and the Banner portfolio, Turk has several different IO-Link masters. You can see here on the right-hand side, we got the 8-port completely connectorized IP67, IP69. Here's the smaller 4-port version on the left-hand side. We also have this little guy here. This is an IP20 solution, goes in a panel. You can get it with or without the DIN rail clip, and it's got 4 IO-Link master channels on it. This is the FEN20. Sometimes people call it the FIN20, and if you don't like it, then we get offended by that. But the IO-Link channels, you got 4 of them. Well, any unused channel can also be used as an input or an output. So here again, you can put some mixed discrete signals for the unused IO-Link channels, as well as connect this to an IO-Link type device to get some absolute feedback. Then on the screen here, we have the slice that we showed in the previous pictures that go onto more of our BL20 platform, where you can plug multiple ones together. One thing that we have in common with all the products we just talked about is they are multi-protocol. You can see these are all Ethernet devices, built-in switch, and then we support, with each piece of hardware, we support the 3 major industrial Ethernet protocols, which is Ethernet IP, Profinet, and Modbus TCP. You don't have to configure it. It recognizes the master that comes on board and then reports accordingly. So if you're an OEM or an integrator and you do some Siemens projects and some Rockwell projects, you could use the same piece of hardware and use it for both different platforms. Now the 3 here, the little FEN20 in my hand, the one on the left, the one on the right, the TBEN style, those also have what we call RG, and that's the bottom bullet point. RG is a web-based control programming software, so you can actually do some local control with each of these devices. I'll give you an example of an application that we solved. Customer contacted us looking for crane collision avoidance, which is a very good idea. But they wanted to use some IO-Link sensors because IO-Link gives them health data. And instead of just measuring the distance from one crane to the other, they were looking for health information. So if anything looked like it shouldn't, they could shut down and do a safe, evaluation of what was taking place. Well, in this application, they needed 2 sensors to measure distance. They needed 2 push buttons so they could set their slow down and their stop set points. And then they needed to control 4 starters. So that's 2 IO-Link devices, 2 discrete inputs, and 4 discrete outputs. Well, these channels, not only do they have an IO-Link on pin 4, which is typically the black wire, they also have a discrete IO point on pin 2, which is the white wire. So we put splitters in there, connected the IO-Link devices to one half of the splitter, which there was only 2 again, and then the other half we were using as push buttons. Well, then these other 2 connections, since we didn't need any more IO-Link connections, you can tell that IO-Link port that, hey, now you're a discrete input. And so we ended up putting the inputs down here. We used the extra output on all 4 of these. And so now we did 2 push buttons, 2 IO-Link sensors, and 4 discrete outputs, all with the one block. And then RG did the crane collision avoidance logic. So without having to buy any enclosures or buy a separate PLC, they were able to do that simple function of collision avoidance and then appropriately stop the contactors. They were concerned, well, what if I need another input or an output? Well, we just pointed them back to the hub here and said, well, anytime you want to, we can add 16 IO to this IP address with that hub. So that's the master side of it. Turk sensors. We have different pressure sensors, temperature sensors, talked about the encoder a little bit. That's this device down here. It's not connected, but it uses an inductive target, and you can handle about 5 to 7 millimeters of separation, so it's non-contact, and it just measures 0 to 360 in an absolute way, so you know exactly where you are in that one revolution. If it's powered...
Hey, Carter, you're not in a slideshow mode, so it may be a little tough to see the products there.
What do you mean?
We're seeing your screen that has the notes on it and things like that.
Oh, no kidding? Well, thank you. Screen share. Aha. How's that?
I got it.
Thank you so much. Okay, so the encoder here, it's a 0 to 360 absolute device, and if it's powered, it will also keep track of turns. So as long as you're not moving when your power's removed, you could use this as a multi-turn absolute device over IO-Link. Then we also get into the RFID readers that I mentioned, linear position devices, ultrasonics, several different things. Get to the banner side of things, laser distance sensors, simple photo eyes, and we'll show you how they're not so simple here in a second with what you can get from them. Color sensor that we'll look at, measuring arrays we talked about, and then indication. And as I have indicated previously, the indication is also, I think, what makes this a game changer. In fact, speaking of indication, let's look here at this TL50. Let's play with the board. You can do different animations with these IO-Link lights. Every one of these segments, and I doubt you'll use a 10 segment very often, but if you use a 3 or a 4 segment, then you can pretty much have your machine tell lots of different stories. Each one has RGB LEDs, so any segment can basically be any color. So let's run through some of the different things we can do with this light. So there we're just showing multiple colors. Here we're in more of a level mode. So if you've got like a tank level and you want to show how full or empty the tank is, you can do something like that. Here's kind of a similar application, except we're changing all the colors at the same time and then flashing red once we get to our high point. This is a rotate feature that we have in a lot of our indication products that's become really popular. You can indicate motors turning. You can even change the direction if you want to indicate that, and you can indicate that, hey, we're a barbershop and we can do haircuts. So all these different animations are things you can do on the fly with your process data. You can do this if you just really want to throw people into a tizzy. In fact, they have more animations than Carter has pills. And if you get that reference, then you're probably older than me, which means you've been a liver for a long time, which means you also got that reference. Little insider, oohs and ahs. To the older group. So now moving over, this is another indication product from Banner, but it's also got a push button actuator. Now the lights through the camera don't come through quite as clear. I think it gets pretty washed out, like a stain in an OxyClean commercial. But what this will do also, you can do lots of different animations, different color patterns. It's got an actuator, so now you can also use this as your push button for your operator. Again, all with one IO-Link device. And here it'll start to do some of the rotation and things like that. And then we'll hook up to this photo eye and kind of get an idea of what the heck can we do with the photo eye over IO-Link. And here I'm going to screen share back to our browser. Share. All right, do y'all see the browser there, Kurt? I think you do.
We do.
All right, let me disconnect the awesome light from Banner just so it's not blinding up the screen. All right, so we mentioned the off and the on and that kind of thing and the health monitoring. But while I was playing with this demo over the weekend, because I don't have much of a life, I also realized some of the things you can do with the process data. So not only can we get these 5 bits of information, but you can also get some secondary information, such as it's got a counter, so you can do like an event counter. You can do a pulse duration, which tells you basically how long the pulse was on for the last set, or you can do rate. And before we do this application, just know I'm putting on my safety glasses. So doing rate I thought was fascinating because to do rate currently, it's a calculation in the PLC. And if it's a pretty fast signal, then you might even have to get a high-speed input card to take care of that. So now I've got my Cobalt / Benford X3 3000 and this little paddle bit helps me make a good target for my product. So what I want you to pay attention to, look on the screen at the rate. So if we get in here to where the sensor is sensing, I don't know if you can see the LED of the sensor or not, but it's turning off and on with the rotations. So now as we get going, you'll see the rate start to climb. So now with this simple, slightly over $100 photo eye, you can get rate information on your line speed or your product speed. But I just kind of wanted to see, well, what the heck will this thing really do? So this is why the safety glasses are here. We ratchet it up and we get going a little faster. And I was like, surely we can't reach ludicrous speed, can we? So let's just see what we can get. The last session we got a little over 5,000 RPM, or EPM. You probably can't hear me. And now we want to see what we can do here. Come on. Now we're up over 5,000. I actually got it up to a little over 6,000 earlier, but now we've got a decent little high-speed rate indicator out in the field. So my end device is actually doing my rate calculation for me and just feeding it back on my IO-Link channel. I've really not seen a way to do that before other than using some expensive devices or doing it back in the PLC. So pretty cool from Banner on that photo eye. So what else do we have here on the demo board? Well, we have a...
Carter?
Yep.
Hey, why do you have an unterminated fiber optic on your board?
Oh, this here? Well, I'm getting up...
you're not connected.
No, I'm getting up in age, Kurt, and my doctor told me that I should start including fiber in more things. So I'm just trying to be a good patient, and I'm going to make sure that I do this regularly. Who's and I? Great question, Kurt. So now we're hooked up to this sensor down here, which is a laser distance sensor. We talked about using measurement sensors instead of analog earlier. If you're looking at the screen, we're getting engineering values in millimeters. So it meant, again, our PLC scaling is really non-existent because I'm reading millimeters directly from the sensor. What else we got up here? We got our color sensor. So let's go look at our color sensor page. This is a true color sensor from Banner, and I've programmed 4 different colors into the sensor, and using the message we're getting over IO-Link, again with that 3-wire cable, should be orange there, absolutely. There's black, there is blue, and oops, and then I got to reteach, it looks like. I bumped it. There's our apple. Oh, there we go. Occasionally we're an apple. So we're getting which color did I teach is coming through the IO-Link message. If you want to do more of a preventive maintenance thing and kind of see if your color starts to deteriorate or change over time, you can also get the actual RGB values over the IO-Link message. So as your product is running, you can see if those values start to deteriorate where you need to change out, print, ink, or something like that. Now let's go over to our temperature probe. So this is the temperature probe earlier that I was talking about that we were just using as analog. Well, it's also got IO-Link. So you can see on the screen that we're getting that temperature measurement. And I was talking to somebody that came to the automation industry before, and they came from the computer industry. So they were trying to get a feel for this. So I said, well, think of the IO-Link master almost like a motherboard, and it's talking to other devices. So if this is our motherboard and this is our probe, as we're starting to get closer to ice baby, then we can send a 16-bit word to the mother. So extra long pause for that one. I was kind of proud of that one. So anyway, we're getting all these different readings right from these devices using that same unshielded cable going into our IO-Link masters. All right. Well, Kurt, that's my demo board of fun. I miss anything that you can think of?
No, I think you got it all. I just dropped a survey into the chat. We would love to get some feedback from those of you that have attended today, not only on Carter's performance, and feel free to be as vicious as you'd like, but also on other topics you'd like us to cover moving forward. Thank you for attending. We're going to stick around a few minutes for questions. We didn't really have many pop up during the presentation, but if you got something, feel free to drop that and we'll address it. Here shortly, we're always available to talk about applications, not just IO Link or anything along those lines. If you'd like more information or application discussions, please get with the distributor that invited you or your local Automated Dynamics guy. If you don't know who that is, feel free to give us a call, adcreps.com, and we can hook you up with the proper person. Be looking for a follow-up email that will include a recording of today's session with pertinent info also that you can share with others throughout your organization. But other than that, we'll hang out for a few minutes for any additional questions. If not, feel free to go about your day, and thanks for joining us.
Yeah, I thought of one other thing here, that I've had an application in the past where the only thing that prevented us from moving forward with IO-Link was they had one analog sensor that was not available in IO-Link, and they didn't want to have an extra IO-Link, an extra analog port. So what Banner, and I've got a sneak peek of it here, but what they're just about to release is they have an adapter like this that will take in an analog input and actually make it IO-Link compatible. So this is one of their ultrasonics that doesn't have IO-Link. It's a voltage unit, and we do a voltage and a current. I could just connect this now. Now I've got this converter speaking to an IO-Link port. So something else we're doing to make it even more conducive to go with that technology. Ooh. And if you're still there, I didn't do this. I knew I forgot something. I talked about the data storage mode earlier, and what all we can do with that. Let me just show that real quick. So here I've got this sensor. People still hanging on? Yeah, a little bit. I've got this sensor that I'm using in multiple places in my facility. Whatever the machine that has this block on it, and the machine that has this block on it. And I want it to be easy to change out, but they also need to run in different modes. So if I connect it to this block, it's going to fire up and tell me this is in what we call dual mode. You can see here with the 3 LEDs across the top, it's telling me what mode that it's in. And this particular mode gives me a percentage readout. So in this application, that's what I want. Maybe I'm sensing a clear object or something like that. But in the other application, I want it to be more of a laser distance sensor. So I'm just going to unplug it from this IO-Link master, plug it into port 3 of this one, eventually. And now when it comes up, you won't see it do anything special. It's just going to come up and start reading in millimeters. And now when we don't have any signal at all, you see those 3 LEDs are gone. Those LEDs are an indicator of what mode that it's in. So just by changing the port that they're on, they immediately got a new configuration up into it, so you could have the same spare at factory defaults and confidently go put it into different applications. So sorry I forgot that, but I thought it was an important thing to talk about. All right, I won't make you do the closing again, Kurt.
Yeah, nobody else jumped into the chat, so I guess we'll shut it down from here. Thanks everybody for joining, and please keep an eye out for our next round of trainings that should come out shortly.
Hey Kurt.
Yeah.
I did some checking on that capacitive sensor from the last question from the last session, and
yeah,
if it's version 1.1 or greater, which actually now is 1.1, but if it's version 1.1 of IO-Link in the device,
the thresholds,
then it supports the automatic data storage.
Gotcha. Perfect. Yeah. Good deal.
That was good to know.
Yep, absolutely.
Hey,